What's up, guys? Zaxby Sauce, aka Confused Insurgent here, back for another hardware guide. So I wanted to do a video going over delidding one of the current gen Intel CPUs. So what happened? Let me actually get out one of the old versions. I have a whole bunch of older Xeon processors here, and by a whole bunch I mean like a bag full of the things. So these have thermal paste on. That's fine. So what used to happen, and these Xeons included, and I think that Xeons actually are still this way today, it's just their consumer line they were trying to save a little money on. What used to happen is that Intel, so this let me get this shot right here. This metal piece right here on the top is called the IHS, or integrated heat spreader. And what it does is it takes the heat. There's actually this green part you see is just the wafer. It has circuitry on it, but it doesn't generate much heat. The actual processing goes on in a little die that's underneath here. It's a little rectangle about that long and about that wide, and it sits underneath there. And the point of the IHS is the die itself is actually fairly small and relatively difficult to. It's a lot of heat concentrated in one small area, so it's not efficient to only pull the heat from that small area into your heatsink. So what the IHS does is it diffuses the heat from the die into this piece of metal here, and then your heatsink connects to this piece of metal and pulls the heat away from the IHS. So what Intel has done for the longest time, and what AMD also does and did for, I think they still do, and they did it for a long time as well, they solder the IHS onto the die. So it is metal to metal, direct metal to metal contact, which is the most efficient heat transfer method you can get basically in this scenario. What Intel started doing in I think the Haswell generation is they, to try to save a little money, they stopped soldering the IHS onto the die and they just glued it on. So they used a thermal adhesive, and it was a very crap thermal adhesive, not a very poor conductor of heat. And so the IHS is now glued on, not in these. This is an older Xeon that still has the IHS soldered on. You can see how much bigger that chip is than the Core i5 I'm working with here. So what that means is that the die generates a lot of heat, and it is poorly conducted to the IHS. The IHS is the section of the chip that actually transfers the heat to your cooler. So no matter how efficient your CPU cooler is, you're only as good as what heat can be transferred to the IHS from the die itself. So what people have started to do is they have delidded, which is to take the IHS off. They have delidded the CPU. So you can then replace the thermal material Intel provides with a better quality thermal material, and then you put the lid back on. You can glue it back on. You can even leave it unglued, really, because your motherboard will hold it on. It's not that big a deal. So they glue it back on, and then you can see temperature drops in the range of sometimes 20 degrees Celsius, depending on the chip you're talking about, which is a big deal, because if your baseline temps drop 20 degrees, and you've got water cooling on top of that, you could be talking about a significant increase in overclocking potential on some chips. So I have done this already. I have a Core i7 6700K, which is a Sandy Bridge, and I delidded it about a week or so ago. I saw pretty drastic decreases in temperatures, about 10 to 15 degrees Celsius drop in temperatures after putting liquid metal on it and relidding it. And I have it running at 5.1 gigahertz on 1.5 volts, which is a little high, but it's fine. If it fries the chip, I'll just get a new one. I'm not really worried. I just wanted to see how high it would go, and I'm just going to leave it there and let it run. I've already had it since I bought it right when Sandy Bridge came out, because I had a 2600K. Sorry, I bought it right when Skylake came out. I think I said Sandy Bridge earlier, but anyway, it's a Skylake chip. I bought it right when Skylake came out because I had a Sandy Bridge before that, and I was waiting for an upgrade that made sense, and it did make sense at the time. The IPC improvement was enough to go ahead and grab one. So anyway, this is an i5 4590. I don't know if you would be able to make that out there. i5 4590. This is from my wife's desktop. So I wanted to show the 6700K, but since I've already done it, the whole process is would not work the same. So I wanted to show you the process from start to finish. So I'm going to do my wife's processor, and if something goes wrong with it, that's fine. She's got a laptop, and she can use that until I buy her a new one. So all good. What I have here is a delidding tool, which I bought online. It was about 20 bucks, I want to say. So the idea here is you take your processor, you line it up, got a little bit of thermal paste on there. There is a triangle right there. You line up the triangle on your processor with the triangle right there, there, and there. Then this this bolt screws down and pushes this metal rectangle with the torque. It torques basically until the IHS is forced off. The glue that holds the IHS breaks, the IHS is forced off the chip. So you take the processor, place it in the bottom piece. You place the top piece on top. They will fit snugly together. If you have the screws near you, you then take the screws. There are 3 holes. These are just to hold the actual delidding tool together while you put the force on it that's going to be required to separate the IHS from the chip, because it does require a pretty decent amount of force. All right, all that screwed into place. As you can see, we have 1, 2, 3 screws here. Now what I'm going to do, I'm going to pull this camera up just a touch. So there we go. So now what we're going to do, you're going to take your Allen wrench that it comes with it, put it in the screw. Actually, to start with, you can just hand do it till it's tight. Once it gets too tight to hand turn, you take your Allen wrench and you're going to start turning. And you're going to wait until you feel a pop. I'm going to put a pretty good grip on it, because last time I did this, there was quite a pop. Okay, there's a lot of pressure. There it is. That wasn't as bad as last time. So I don't know if you could even hear that, but the IHS popped off. Now we can unscrew. Just like that. And I should be able to just lift, but let me take it out of this first. Well, I swear I could, oh, there it goes, okay. It is loose, it's just the glue's holding it on a little more than I thought it was going to. So let me grab one of these pliers from my iFixit kit here. These things are pretty neat. So if this happens to yours, just take it, pry underneath, just like that, and the IHS will separate. Boom. So right there in the middle is your die, right there. You can see there's a little bit of thermal paste on it, not a whole lot. And there's glue. This is all thermal adhesive, or basically just straight glue around the edges. And then right here, you can see there's glue around the edges of this, and then some really poor quality thermal paste right there. I mean, just kind of peels off there. Now that we are back in action. So what you're going to do now is, the first thing you want to do is you want to get all this old thermal paste off. So if you can see here, I'm going to just kind of scrape at it with the scraper tool, and it's going to come off very easily. I'll wipe that away. So that you just want to get the big chunks off right now. You're not worried about getting it super clean at the moment. So as you can see here, just taking the scraper tool, getting those little pieces of gunk off. There's not even any on the die itself, which is not great. Now what we want to do, now that the thermal paste is off, before we do the final clean, we want to get this rubber gunk off. Now this part, depending on how well set in it is, may require a razor. Now you want to have steady hands. Be careful. Not because the razor is dangerous, but because if you scratch too deeply into the PCB here, into the green areas, you may fry the entire chip. So just keep a steady hand, keep the razor pretty flat, don't apply too much pressure, and just scrape. It should come off very easily. Anything that doesn't come off in the first pass, you can get off in the second. So as you can see, it's just coming right off there. It's all about steady, even pressure. You should feel it slide. There shouldn't be any, it shouldn't grab at your razor. It should be like shaving on a clean face. You know, if you've shaved, you know, the day after you just shaved, and your hair doesn't grow out that much. That should be about what it feels like. Just there's no hair to even pull at the blade. You're just kind of scraping the skin. So that actually worked out pretty well. As you can see, there's still a little bit left, but it's not too bad. And those little bit extra, you just take your blade and just work at it. Just apply a little bit of pressure, not too much. Again, you don't want to feel the blade bite into the board. That's when you're getting in trouble. So just a little bit like that. If you feel the blade start to bite, just pick it up. Stop whatever you're doing. Move on to another section. Because that one's just not meant to be. I just felt it bite a little bit right there, and I just picked it right back up. No big deal. Okay? That's about as good as that one's going to get. I'll come back with the alcohol and try to clean that up. Now you're going to do the same thing on this. Do whatever you want. Doesn't matter. This is just straight metal. Has nothing to do with the processing at all. There is no circuitry on this thing. So you can put as much force down as you want. Scrapes and scratches will not matter. Just get it clean. The major thing you want is what we're trying to do here. So Intel put this glue on here, and this glue also creates separation between the die and the IHS. You don't want that. You want as much contact between the die and the IHS as possible. Now, a lot of people don't do this step, but I think this is a pretty integral step to the process. What I would like to do at some point is try it with having scraped off the excess glue and not having scraped off the excess, and see if there's a noticeable difference. There may not be, but it makes me feel better to know that the IHS is touching as cleanly as possible. But like I said, I haven't done the testing. I've always done it just scraping all this crap off. Now this stuff in the interior, not super necessary because it's not actually causing a gap to form. But I like it to look a little cleaner. I'm not going to get all of it because that would take forever. Let me try this one real quick. But if I can get most of it, it'll make me feel a little better. Just like that. Tap it off. Let's see. You can see right there. My hand's gonna be in the way here, but that's fine. I'm just trying to get the last little bits of gunk off. Okay, let me just clean up the work area. And by that, I mean just sweep all this off the table. Keep the razor. Oh, well, you don't have to. If you have a bunch of them, then, do what you want to do. It's your razor. They're cheap. Do whatever you want to, really. I don't want to tell you what to do with your razors. Now, what we want to do is clean these puppies off good. As you can see, there is some residue right there. We want to get all that gone. So you're going to take a paper towel. Just one little flimsy sheet of paper towel will work. Fold it a couple times. First things first, do a couple swipes with a clean, dry paper towel. Okay? You just want to start you want to pick up any oils, anything like that off there. Go ahead and get that off. As you can see, there's actually a little bit of gunk on there already. Now what you want to do, flip it over, spin it, twist it, bop it, whatever you feel is necessary. And take you some alcohol. This is 91% isopropyl, but anything 70% and above, perfectly fine. Take the alcohol and scrape it. If you've got some 70%, I don't know, vodka or absinthe or something, vodka is only 50% usually, but if you've got like absinthe, I guess you could use it too. And you just want to get it till it shines. Really worry about the part that's going to make contact with the actual die. But if you want to clean up around the glue areas as well, that's perfectly fine. It's up to you. In this case, I'm going to also clean up the PCB a little bit. Unnecessary, but makes me feel better. Get a nice clean processor here. Now, the alcohol will, of course, evaporate almost instantly, and you'll be left with something that looks a little bit like that. You can see that reflection on there. That is sweet. Let me just make a little, I think there's a little bit of residue left here still. Really want to put some force down on it. Okay, that's about as clean as it's going to get. You can see there's still some heat residue left there. You may not be able to get that off at all, depending on how long the processor's been running with the IHS on. Now what we're going to do, we're going to take our liquid metal thermal interface material. You don't have to use liquid metal. You could use anything, Arctic Cooling MX4, any decent brand of thermal interface material is going to be better than what Intel was using. The only problem with the thermal compounds, especially the runnier kinds like MX4, over time with the amount of pressure that's put on the IHS, between the IHS and the CPU die and the heat that's generated, may cause non-metallic to spread out and then go down the sides of the die and leave the top. So, and then you're going to have bad contact between the top of the die and the IHS, and you're going to be right back where you started. So really use the liquid metal if you can. Now, liquid metal, if you saw my GPU video, you know that liquid metal, a little bit goes a long way. So you don't want a pea size, you don't want a grain of rice size, you want, I don't know, like DNA sized drop. I don't really know what to compare it to. Like a grain of sand size drop on this thing. This stuff is electrically conductive, folks. You see all these transistors and all of this exposed circuitry on here. If you get the liquid metal thermal interface material onto those and you don't get it off all the way, you could easily fry your chip. Not 100%, it will not always happen, but it could. Whereas with the grease, that's 0% chance of that happening. So keep that in mind. Be very careful. You may even want to tape this thing off. A lot of people, they'll put duct tape, not duct tape. What word am I looking for here? Masking, scotch tape. They'll put scotch tape on each side to cover it up, like as if they're painting a wall or something. I don't usually have any problems with getting it off the die, but having said that, now I may actually, I'll probably do it this time. I'm gonna start with that much. That's probably more than enough. You can see what kind of size I'm working with there. Now you're going to take your Q-tip. Just a normal Q-tip will work fine. Some of these actually come with a little like paintbrush, which is even nicer, but the Q-tip works fine. Let me make sure you can see what I'm doing here. Okay. I'm gonna move the camera down just a touch and over. Okay, now you're gonna take this Q-tip and just start spreading it on, and it's not gonna want to spread. It looks and behaves a lot like mercury. It wants to stick to itself. It does not want to come apart. But as it spreads, a glossy, mirror-like finish will develop on the die. And you just want to put it everywhere. Get that mirror finish all over the chip. Okay, that looks good. Right there. Now, I've seen a lot of people where it's like glass. I think that's too much. I think that when you put that much on there with the amount of pressure that is going to be on the IHS pressing down on this die, you're just asking for it to spread over the edge and hit the PCB itself. This is more than enough. Now what you want to do is take this little bit that's left on the edge of your Q-tip, take the IHS, and just draw it on here in the shape, the general area where the chip is going to touch. You're not going to get a lot, and that's fine. See, it's spreading Just keep brushing it. Eventually, it will spread on there. It'll go into the little gaps and fissures in the metal, because no metal is machined perfectly. The little gaps and fissures will grab onto it, and then you're good to go. As you can see right there. Now what we want to do is grab, first you want to take this puppy and close it, because that is a real syringe, ladies and gentlemen, and that will stab you. And as I said in the previous video, this will not make you into the T1000, as far as I know. I haven't tried it. Now what you want to do is take your relid tool, which is right here. You want to take the bottom of the delid tool, place it down like so. You want to take your CPU and place it back in the delid tool as it was originally oriented, like so. Take your IHS. You can use any epoxy or glue that stands up to high temperatures well. You can also use thermal adhesive if you want, like Arctic Cooling's thermal adhesive stuff, which I don't remember the name of, but anything like that's fine. So just take your IHS very gently. You don't want a lot here. Like that. Try not to get it on yourself. I just do all four sides, a little bit on all four sides. That way you can get it back off later if you need to. Well, I mean, if you got enough force, you can get it back off regardless, but you know what I mean. And actually, I might have put that on a little early because I need to put this on first. The relid tool will also come with this plastic topper. So you just place it. I think I got it backwards there. Like so. And it kind of guides your hand when you put the actual lid back on. So now turn it and just place it gently back into place. Like that. Press down. Then take this. There are these screws. The same screws you used earlier will screw down into the bottom of the delid tool. Okay, make sure you can see that. You're just screwing right down into those two places till they're tight. Now take this big screw, twist it till it makes firm and even contact with the IHS. Just like that. Now, you're just going to leave this for, 1 to 2 hours should be good. You don't actually have to even do this step. Like I said earlier, you could just put it back in the motherboard and let the retention mechanism hold it in place. You could also just go ahead and glue it and then immediately put it back in the motherboard and let the retention mechanism hold it as it cures. It might take a little extra time because of the added heat involved, but that's fine. And that is it. You're relidded, ready to go. So next up, I will, once this cures, I will put it back in the PC and I will display on screen the relidded temperature results. So here's the temperature results, guys. As you can see, the orange bar is going to be the pre-TIM replacement bar. The purple bar will be post-TIM replacement, and the blue bar is post-delid, so the temps after delidding the processor. And these are average temps across all 4 cores on the left, and then average maximum temperatures across all 4 cores on the right. So you can see the results previous to replacing the TIM. This was stock using the Dell stock cooler with the side panel closed, everything completely stock, running IDA64 for 10 minutes. We averaged a temperature of 70.75 degrees Celsius, and we had a maximum across all 4 cores during the test of 76.5 degrees Celsius. After replacing the thermal interface material with Arctic Silver, we had an average of 73.5 degrees Celsius across all 4 cores with a maximum of 78.5. It's a little odd that actually increased temperatures over using the Dell default TIM. I'm not sure why that happened exactly. Maybe the TIM replacement needed some time to burn in. I'm not positive. Kind of a weird result, but it was a consistent result. Then after delidding, temps dropped precipitously. So we had an average across all 4 cores after 10 minutes of IDA64 stress test of 65.75 degrees Celsius, which was a 5-degree average drop, and then a max drop of max dropped all the way down to 69 degrees Celsius, which would be a 7-degree drop from the stock TIM and stock results. So that's a pretty good result. 5 to 7 degrees Celsius is pretty good. And the average, the ambient temperature in the room never exceeded 18.5 degrees Celsius. It was between 18 and 18.5 the entire time. That's a great result, though. And remember, this is an i5 4690. It's not even a K. It's not unlocked. It's not overclocked. So this isn't an overly warm processor to start with, as you can tell by how well the Dell stock cooler is handling the environment. So is it worth it? My recommendation would be, if you already have one of these DLID tools and you did it on one of your other processors and you want to go ahead and do it on your other systems, then I'd say go for it. I mean, it's certainly a worthwhile process. I had fun doing it. I have fun doing little projects like this regardless. And it's easy, it's simple. You will void your warranty, but I mean, this system didn't have a warranty anymore anyway, so no big deal there. If you don't already have a DLID tool, I don't think the $20 to $30 investment would be worth it for a system like this. For a high-end system, if you're running an i7, quad core from any of the past few generations, all the way down to Haswell, this is something that's probably worth it. You can see significant temperature decreases. My i7 6700K temperatures dropped down 10 to 15 degrees Celsius across all 4 cores, which is crazy. Just making that one change. So that's it, guys. Thanks for watching. If you have any questions or comments, make sure to drop them down below, and I will see you guys next time. Bye-bye.